to the 2 points. Go ahead and, like always, complete each problem on a sheet of notebook paper. Come in with questions. Be ready, study. Be ready for your quiz 100%. Let's start off with a quick review of rounding. This says round to the nearest hundredths. So we underline the digit in the hundredths place, which happens to be 2 decimals to the right, 2 place values to the right of the decimal, which is the 8. So we underline that 8. Draw a hook and arrow to the indicator, the digit right before it. It's a 6. Remember, 0 through 4 tells us to leave it alone. 5 through 9 tells us to bump it up. That's a 6, so we're going to bump up the 8 to a 9. 6 and the 2 and anything to the right becomes zeros. And in decimal land, we cut it off, and we always rewrite our final answer. Final answer would be 54 and 79 hundredths. Next problem, round to nearest thousandths. Same idea, but this time we underline the digit in the thousandths place, which happens to be the 6. Hook and arrow to the 2. 2 tells us to leave the 6 alone. 2 becomes a 0, and anything to the right becomes 0. Cut it off, rewrite your final answer, 54 and 786 thousandths. Now from the book, 2.4 to 2.6 quiz. Number 1 and 2, they say add or subtract. I'm only going to do one of these. I'll do number 1. 6.329, as you should always know, whenever you're going to add or subtract decimals, you must line up your place values, meaning line up those decimals. In any place value that has a blank spot, we'll put a placeholder in there, put a 0. And now you just add column addition like you did back in 1st and 2nd grade. 9 plus 0, 9. 2 plus 8 is 10, carry the 1. That equals 7, decimal point. 6 and 4 is 10, carry the 1, and 2. Final answer, 20.709. Now you go ahead and do number 2. And let's take a look at 3 and 4. Again, these are both subtraction problems. So I'm going to do number 3 only, but you go ahead and you also do number 4. So 85.8 minus 2.354. Again, the key when you are adding or subtracting, you must line up those place values. So line up those decimals. Everything else should fall into place. And if you have any blank spots, you must tack on a 0 as a placeholder. Subtraction. 0 minus 4, can't do. We borrow the can't do, so it borrows from the 8, becomes a 7. This becomes a 10, and then now we can borrow, now it becomes a 9, and the 0 becomes a 10. 10 minus 4, 6. 9 minus 5, 4. 7 minus 3, 4. Decimal point, just line up your decimals. 5 minus 2 is 3, and 8 minus 0 is 8. So your final answer, 83 and 446 thousandths. 83.446. Again, you go ahead and do number 4 for practice. Numbers 5 and 6. Multiplication with decimals. First step, as you learned with the magic number, Mr. Heller's magic number strategy, always make an estimate. 7.6, I'm going to estimate that as 8. And 8 times 5, we all should know is 40. Our final answer should be about 40, but we overestimate it. So we know the real answer will be a little bit under 40. That being said, we can now count the magic numbers. The digits to the right of the decimal, we have 1. So the magic number for this problem is 1. And now we treat it like whole numbers and just multiply. 5 times 6 is 30, carry to 3. 5 times 7 is 35, plus 3 is 38. So we have an answer right now of 380. But again, using our estimate, we know the answer should be about 40. Where does that decimal go? The only place it can go to make any logical sense. And we have one magic number, meaning we start on the right-hand side, and we can insert our decimal 1 place value to the left. So it belongs right here, 38.0, also known as just 38 wholes. Number 6, 0.62, that's about 1/2. And half of 17 is about 8.5, 8.5. So our answer should be about 8.5. It'll be around there. Now we can count the magic numbers. We have 2. So 2 is our magic number for number 6. And now we multiply. 7 times 2 is 14. Carry the 1. 7 times 6 is 42, plus 1 is 43. And 7 times 0 plus the 4 is 4. Placeholder, because I'm going over moving place value. So now it's 1 times 2, 1 times 6, and 1 times 0 is 0. I don't even need to write it. I get a 4, I get a 5, I get a 10. And again, my answer should be about 8.5. So I already know exactly where I want to put that decimal. And I can verify it with my magic numbers. 2 place values to the left. 1, 2, and plot it in. And the answer is 10.54. Now you go ahead and do exactly the same thing. You try number 7, and then you go ahead and complete number 8 as well. Good practice. Now we get to division. 8.4 divided by 5. Well, you look at your divisor first. Do you have a decimal out here? And the answer is no. So that's great news. All we have to do is take care of business first when we're dividing and bring the decimal straight up into our quotient. So I'm going to go ahead and place it right here. And once I place it right there, I can now go ahead and just simply ignore the decimal, treat them like whole numbers, and I do regular division. How many 5s can go into 8 without going over? 1. 1 times 5 is 5. Subtract, the difference is 3. Checkpoint, is 3 less than 5? It is. We may proceed. Draw an arrow, bring down that next digit, which is a 4. 5 goes into 34, 6 times, which is 30. Subtract, I get a difference of 4. Now I have no more digits, and we learned in class, when we are dividing with decimals, no more digits, but we still have a number here, we can annex zeros. We can tack on a 0 and bring it on down, and now it becomes 40. And we keep our quotient moving. 5 goes into 40 8 times, which is exactly 40. Subtract, nothing left over, no more digits to bring down. This is our stopping point. Our final quotient, our answer, 1.68. Number 11, 5.6 divided by 0.7. So you can see how I went from the division symbol and used the division little house symbol. Now we do have a decimal in our divisor, and we don't ever want a decimal in our divisor. So as we learned in class, we are going to go ahead and multiply our divisor by 10, which moves the decimal one place to the right. But whatever I do to my divisor, I better and I must do the same exact thing to my dividend. So I'm going to multiply this whole thing by 10, which moves the decimal one place value to the right. So now I'm going to rewrite my problem, which is simply 56 divided by 7. And you're allowed to do that in division, as we talked about. As long as you do to both, the same thing to both, your dividend and your divisor, you're not changing the quotient at all. And now it actually turns out to be a really simple problem. It's just 56 divided by 7, which is a basic fact of 8. So our quotient, the answer, is simply 8. A field hockey field is rectangular. Key information. Its width is right there, 54.88 meters. Its length is 91.46 meters. Find the perimeter of the field. So the easiest thing you should do is draw yourself a picture real fast. It's a rectangle. It's a field. So there it is. It's not the most beautiful rectangle, but it works. Its width, the wide section, 54.88. And its length, 91.46. It's a rectangle. Rectangle means if I know the left side is 91.46, I know that right side is congruent, exactly the same, 91.46. And if the bottom is 54.88, that top section must also be 54.88 meters wide. Now a perimeter. To find a perimeter of any shape, we simply add the outside, the distance around the outside of the figure. So we need to simply add up 54.88 plus another 54.88 plus 91.46 plus another 91.46. Again, we're adding 4 decimals at the same time, which is okay. Just line up your place value. Those decimals should be lined up. And we have 16 and 12, it's 28. Carry the 2. And then we have 10 plus 8 is 18. 18 and 4 is 22. 22 and 4 is 26. Carry the 2. And then we have 8 plus 2 more is 10. 11, 12. Put on the 2, carry the 1. 10 plus 10 is 20 and 9, so 29. So our final answer, the perimeter of this field is 292.68 meters. Find the area of the mouth of the field hockey goal. So area, the mouth is going to be right here, the front section, which is simply a rectangle. Area of a rectangle, area is equal to length times width, as you should remember from 4th and 5th grade. So it's really just 3.66 times 2.14. First thing I want to do, since we are multiplying decimals, make an estimate. That's about 4, that's about 2. Our final answer should be about 8. Count my magic numbers. I see 4, so the magic numbers would be 4. Now I ignore the decimal and simply multiply. 4 times 6 is 24. 24 and 2 is 26. 12 and 2 is 14. Placeholder. 1 times 6, 1 times 6, 1 times 3. Now I put 2 zeros because I'm moving 2 place values over. So I have 2 placeholders. And it's the 2's turn. 2 times 6 is 12. Carry the 1. 2 times 6 is 12. Plus 1 is 13. Carry a 1. 2 times 3 is 6. Plus 1 is 7. Add them all together. 4, that becomes a 12. That's a 13. That becomes 8. And I have a 7. So I'm looking at this as 78,324. I already told myself the final answer must be close to 8, as our estimate tells us. And I have to put that decimal back in 4 place values to the left, which they should always match up. 1, 2, 3, 4. Final answer, 7.8324 square meters is my final answer. And that makes logical sense because I said it should be about 8. And that answer is very close, about 8. Here's a bar graph. Letter A, suppose the attendance was the same each month in 2008, which is right here. How many people attended each month? Well, 15.3 million people. They came in each month about the same, so I can simply say 15.3 divided by 12. Decimal point, first step, goes straight up here. And 12 goes into 15 one time, which is 12. Subtract, we get 3. Bring down 3. 12 goes into 33 twice, which is 24. Subtract, we get 9. Tack on a 0, bring it on down. 12 goes into 90. 12 times 8 is going to be 96, which is too many. So 12 times 7, which is 84. Difference is 6. And now it's getting ugly because I'm kind of running out of room. But let me drag this up a little bit. And keep it going. So 84 subtract is 6. Tack on one more 0. Bring it on down. 12 goes into 60, which is 5 times. And our final answer for part A, 1.275. And these people are in millions, according to the graph. So 1.275 million people per month. And the last section says how many times more people attended in 2006, 17.1 million, then in 2009, which is 14.3 million. To do this, we're going to simply divide 17.1 divided by 14.3. Again, we have to get rid of our divisor, a decimal in our divisor, multiply by 10. And that means also multiply this by 10. And really, it's just 171 divided by 143 at this point. You'll go ahead and solve that. You'll end up with 1 point something as you finish it out. And it'll be 1 point something times greater. And that is our interactive study guide. Again, review each problem, study, practice, come in with questions. 100%. Goodbye.